Hello everyone, welcome to this video. In this video, we'll be seeing this question which states that suppose G is the group for which we have this Cayley table given to us, right? Now they are asking we need to find the centralizer of each member of G. So let's move forward and solve this part only. So if you remember what is the definition of a centralizer of some element A within G, right? A is some element of G. Now you wanted to calculate its centralizer, then it contains all those elements of the group G such that such that element X would commute with A, right? XA would be equal to AX. So for calculating the centralizer of A, so we centralizer of 1, right, we are simply here in this particular case we are looking for all those X belongs to G such that X commutes with 1, right? And you see 1, because in this Cayley table 1 acts as the identity, so 1 star 1 is 1, 1 star 1 is 1, so 1 commutes with 1. 2 star 1 is 2, 2 star 1 is again 2, 1 star 3 is 3, 3 star 1 is 3, right? 1 star 4 is 4, 4 star 1 is 4, 1 star 5 is 5, 5 star 1 is also 5. So you see all of them, they are equal to each other. 1 star 6 is 6, 6 star 1 is also 6, so they are also equal. 1 star 7 is 7, 7 star 1 is 7, and 1 star 8 is 8, 8 star 1 is also 8. So you see all of them, they are equal to each other. Hence all the members in this case come into the set of centralizer of 1. Why? Because in this particular case all the members commute here, because actually this is the identity element. So this consists of whole of our group G. What about the centralizer of 2? So here we are looking for all those elements from the group such that they commute with 2, right? So let's see. So obviously 1 would come here, 1 star 2 is equal to 2, right? And 2 star 1 is equal to 2. So they match, right? What about the other element? So definitely 1 would come here. What about the other element? Let's have a look. Does 2 commute with itself? 2 star 2 is 1 and 2 star 2 is again 1. So obviously 2 would come here, right? What about the next element? 3. 2 star 3 is 8. Then 3 star 2 is 4, right? They are not equal to each other. So that means 3 won't come here. What about 4? Let's have a look. 4 star 2 is 3, right? And 2 star 4 is 7. They are also not equal to each other. So 4 would not come. What about 5? 2 star 5 is 6, 5 star 2 is 6. Yes, they are equal. So that means 5 would definitely come here within this set, right? So we have 1, 2 and 5. What about the other elements? So let's see. What about 6? 2 star 6 is 5 and 6 star 2 is what? It is also 5. So they are equal. Hence 6 would also come here. What about 7 and 8? So let's see about 7 and 8. 2 star 7 is 4, 7 star 2 is 8. They are not equal to each other. What about 8? 2 star 8 is 3, 8 star 2 is 7. They are also not equal to each other. Hence for the centralizer of 2, we have only the elements 1, 2, 5 and 6 with us. Similarly for the centralizer of 3. So here we will have to check for all those elements X belongs to G such that they commute with 3, right? So the procedure is similar. You just have to do the same. 3 star 1 would be equal to 1 star 3, which is 3, right? So 1 would be there. What about 2? 3 star 2 is 4 and 2 star 3 is 8. They are not equal to each other. So 2 would not come here, right? So we only have 1 until now. What about 3? 3 star 3 is 5. So obviously it would come here. 3 would come here, not 5. 5 is the answer. Next about 4. 3 star 4 is 6. 4 star 3 is what? 2. Not equal to each other. What about 5? 3 star 5 is 7. 5 star 3 is 7. Yes, they are equal. Hence, we can write 5 here. What about 6? 3 star 6 is 8. 6 star 3 is 4. Not equal. Then 3 star 7 is 1. 7 star 3 is also 1. Yes, 7 would come here, right? What about 8? 3 star 8 is 2. 8 star 2 is 7. They are not equal to each other, right? So have I missed anything? 1, 3, 5 and 7 would be there. 3, okay. I have not written 3 here. 3 should also be here. Why? Because when you commute 3 with 3, you get 5. So obviously 3 star 3 would be 5 and 3 star 3 would also be equal to 5. Hence they commute. So this would be the centralizer of 3. In a similar manner, you can calculate, pause the video, calculate it for C4, C5, C6, C7 and C8 and check for your answers. The procedure I have told you how you can proceed. Okay, so you can verify the answer. Next question is, we need to find the center of this group. Now, if you remember the definition of center, it consists of all those members from the group G such that they commute with all the members of G, right? So, and if you remember in some previous question, we have also showed that the centralizer, the intersection of all the centralizers would be the center of the group, right? Now, why I am using this result over here? Because we have all the centralizers present with us. So here within the centralizers, you can clearly see the elements which are common in each is, you can see 1 appears in each. Does 2 appear in each? 2 is here, 2 is here, 2 is not here. So what about 3? 3 is here, 3 is not here. 4 is here, not here. 5, yes, it is here, yes, 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 it is here, 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 here and here as well. So 5 also comes in each. What about 6? 6 is here, 6 is here, 6 is not here. 7 is here, 7 is not here. 8 is not here. So you see only the elements 1 and 5, they appear in all the centralizers. Hence our center becomes 1 and 5 because they compute with each of the members of the group G. Correct? What about the third part? In the third part, they are saying find the order of each element of G. First of all, this thing, and so let's do that first. So for the order, if you remember, we have to apply that operation how many times so that we obtain the identity. The lowest number of such times we have to perform becomes the order. Here the order of group G is 8 because it consists of 8 elements within it. The order of 1 is 1 because 1 give you 1, right? Order of 2 is 2 because 2 star 2 is 1. You can clearly see from this Kelly table. This 2 star with 2 gives you 1, right? So you have to do it 2 times. Then the order of 3 is 4. Why? Because when you perform 3 star 3 star 3 star 3 4 times, so you see you obtain 1. How? When you solve 3 star 3, you have 3 star 3 you have 5 and 3 star 3 you have 5. 5 star 5 is 1, right? So you have 1 here, which is the identity element. So this is also done. What about the next part? Order of 4. Order 4, the order of 4, 5, 6 and 8, they are equal to 2. How? Why? Because you see here in this particular case, 4 star with 4 is 1, right? 6 star with 6 is 1. In fact, 5 star with 5 is also 1, right? And then 8 star with 8 is also 1, right? 2 star with 2 is also 1. 1 star with 1 is also 1. So you see all these elements have order 2. What about the last element, which is our element 7? So you see we have its order as equal to 4. Why? Because when you perform the operation 7 times, 7 star with 7, star with 7, star with 7. So once you perform this 7 star 7 and 7 star 7, you get 5. 7 star with 7 is 5. And again 7 star with 7 is 5 and 5 star with 5 is 1. So you see you obtain 1 in this particular case. So here for this particular case you have 1 when you perform it 4 times, hence the order is 4. Hence you see the order of each element here is either 1, 2 or 4, and the group order of the group is 8. So the next question they are asking here is, how are these orders arithmetically related to the order of the group? So you can very clearly say that here the order of each element clearly divides the order of the group G, and this is what is the answer to this particular question. So I hope you understood this question well. That is it for this video. Thank you for watching.